Hi everyone, this is Mrs. Turigno, and this is page 5 of your Algebra 1B first semester exam review, the first packet. I'm actually starting at the bottom of page 4 with problem number 29, and then this video will go through problem number 32. Okay, problem number 29 is talking about weighted averages. And I want you to pay particular attention to this question because this is how your grades are calculated in my class. Okay? You are calculating your semester exam grade, your semester grade in Algebra 1. And then this goes to describe how the first and second marking periods are weighted. They are weighted to be worth 42% each of your final semester grade, and then the exam is worth the other 16%. And the next little section is talking about your actual first quarter scores and your second quarter scores. Okay? So here's how your grade is calculated. First, we're going to calculate first quarter by itself. And then we're going to calculate second quarter. And then, of course, we have your exam score. And I think most of you are pretty familiar with this system, that these are the three components of your final semester grade. When we go to look at first quarter, we have 4 equally weighted scores here, 72, 84, 76, and 91. So to find your first quarter grade, we're really just doing a regular average. These are the averages or the mean that you've done for a long time in math. I'm just going to take these 4 scores and add them together. So 72 plus 84 plus 76 plus 91. And then remember, to find an average, we want to divide by how many scores I have here. I have 4 scores, so I'm going to take this sum here and divide by 4. Now, it is possible to type this all into your calculator in one shot. But in order to do that, you need to be careful that you let your calculator know that these numbers need to be added together first before the division is done. The best way to do that is to use parentheses like I've done here. Okay, let me show you what that would look like in your calculator. Like I said, make sure you use parentheses. I'm going to type in 72 plus 84 plus 76 plus 91. Close off those parentheses and divide by 4. And that gives me an 80.75. I would be careful not to round this early in the problem. I'm just going to stick with that 80.75. So that would be my first quarter grade. We're going to do second quarter the exact same way. So here are my second quarter grades, 68, 79, 71, and 86. And again, I'm going to want to use parentheses on the top of that division problem. And again, I'm dividing by 4 because I have 4 scores given to me. So in my calculator, I would type in 68 plus 79 plus 71 plus 86. Close off the parentheses and divide by 4. And that gives me a quarter 2 average of 76. Okay. The exam grade I really don't need to calculate because it's just given to me in the problem. It says right here that you score an 82% on the exam. So my exam grade down here is an 82. So these are the 3 grades that are going to make up my final grade. But these are not equally weighted, as it describes at the beginning of the problem. Each one of these are worth 42% of your grade, and this is worth 16%. So to apply those weightings, I'm going to multiply each one by its weight as a decimal. So I'll take this one and multiply by 0.42 for 42%. I'll take this one and multiply by 0.42. And then I'll take this one and multiply by 0.16. Once I've done those multiplications, I can add these 3 components together, and that will give me my final semester grade. And this you can actually type into your calculator just as is. You could do it all in one shot. If you wanted to do these as 3 separate pieces and then add together, you could. But just to save you some time, we're going to do 0.42 times 80.75 plus 0.42 times 76 plus 0.16 times 82. And that gives me a 78.955. I would probably just round that up to a 79. Okay, so that 79 would be my final semester 1 average, which is what the question is asking for. Okay. Let's give that a try on the next problem, because the next problem is very similar. We're going to use the exact same method. So problem 30 is another weighted average problem. This one, the weights are a little bit different, but it's still going to use the exact same method. I would start by setting up quarter 1, quarter 2, and your exam grade. Okay. Again, it gives me that my quarter 1 scores were 86, 95, 92, and 79. In my calculator, I'm going to want to use parentheses around those, and then divide by 4. So 86, oh, not following my own advice, parentheses, 86 plus 95 plus 92 plus 79, close parentheses and divide by 4. And that gives me an average of 88 for quarter 1. Quarter 2, I have an 86, a 78, a 90, and an 84. And divide by 4. So, parenthesis 86 plus 78 plus 90 plus 84, close parentheses and divide by 4. And it looks like an average of 84.5 for quarter 2. And it looks like my semester exam grade was an 87. Okay, now it's time to apply the weights. And this time up here, it gives me that the first and second marking period are worth 40%. So that means I'm going to multiply each one of these by 0.40. 0.40. And then that means my semester exam grade would be 20%. So I'm going to multiply by 0.20. I'll add those 3 pieces together. So 0.40 times 88 plus 0.40 times 84.5 plus 0.20 times 87. And you end up with a final semester 1 average of 86.4. That would not round up to 87, but if you left it as just 86, that would be acceptable too. But my final average for semester 1 here would be 86.4. Okay. Now these problems, it's really important to think back once you get your final answer to see if your final answer makes sense in terms of the problem. Okay? It looks like here our final average was 86.4, and if you look at all of your scores, it looks like 86 would be a reasonable average. If you did this problem and found that your semester average was 124.7 or something like that, hopefully it would set off a red flag in your mind that you had done something wrong. Similarly, if you had gotten all of these grades all throughout the semester and you got your report card at the end and it said that your final average was a 49%, hopefully you would catch that that's not correct either. So just look back at the problem, look back at the scores, and see if your average makes sense with what your grades were. Okay? Okay, on to number 31, which is a graphing question. We learned a lot of different ways to graph these linear equations. So I'm going to show you one way and then sort of explain to you another way that you could have taken if you had wanted to. I think usually the easiest way to graph, especially when your equations are in this standard form, which means that x and y are together on one side, the easiest way to graph is probably to find the intercepts. So I would start by finding the x-intercept. Remember, at the x-intercept, y is equal to 0. So that means that this y term would cancel out and I would be left with just x equals 8. Okay, if that y term was canceled out, see if you can see that. But if the y term was canceled out, you would just have x on this side and equals 8 over here on this other side. So my x-intercept is at 8. Okay. If I were looking for my y-intercept, that means my x term would be equal to 0, and I would have 2y equals 8. If I divided both sides by 2, I would end up with y equals 4. So that would be 0, 4. Most important thing to remember when using this method is that these are two separate points. All right, you don't want to put them together and plot them as one coordinate. This is a point on the x-axis and this is a point on the y-axis, and then you'll connect them. So I would go to the point x equals 8. Okay, put a point there. And then I would go to the point y equals 4 and put a point there. And then you could just connect them with a line. How embarrassing will it be to draw a not straight line on a YouTube video? I've done better. I've done worse. Okay, so there's one way to graph this linear equation. The other thing you could do, so this down here is where I'm going to show you the other method you could use, is you could take this equation and put it in slope-intercept form. And slope-intercept form is y equals mx plus b. To get it into that form, I would just focus on getting y by itself. So I would probably start here by subtracting x from each side. So I would end up with 2y equals, and I'm going to put the x first because in slope-intercept form the x comes before the constant. So that would be negative x and then a positive 8. And then I'm going to divide everything by 2. Okay. That would leave me with y equals, now where I have negative x over 2, you could also think of this as negative 1x over 2 or negative 1/2 x. And then 8 over 2 is 4. Okay. If you were to use this method, or if you were to have an equation that started out in this format, this is how you would graph it. I would start at the y-intercept. Remember, this b term, this number on the end, is always your y-intercept. So I would start on the graph at the 4 on the y-axis, put a point there. Obviously, there's already a point, but that's where you would start. And then my slope here is negative 1/2. And remember, slope is rise over run. So this would tell me to go down 1 and to the right 2. So from that starting point, I would go down 1 and to the right 2. Down 1 and to the right 2. And hopefully you can see that that's making the exact same line. Oh, I'm sorry, you can't see that. Let me demonstrate that again. I would start from the y-intercept, and that slope tells me to go down 1 and to the right 2. So that's where this point came from. Then I could do it again. Go down 1 and to the right 2. And hopefully you'll see that those points are forming the exact same line that I had there to begin with. So that is just another option for graphing one of these equations. Okay, on to number 32. 32 works a little bit differently. Hopefully when you look at problem 32, the first thing you'll notice is that there's no y in this equation. Usually linear equations have an x and a y in them, but this one only has an x. Well, let's start by getting that x by itself, because that's always helpful. And here I would end up with x equals negative 2. And then I want you to think about what kind of line that really is. Remember we talked, I believe it was just on the last page, that anytime you have an equation that's just x equals a number, that's going to be a vertical line. And that's really something you should just work on knowing off the top of your head, that x equals a number will always form a vertical line. I'm going to go to negative 2 on the x-axis, and then I want my line to show me all of the points on this graph where x is equal to negative 2. That would fall anywhere along this vertical line. Okay, so that's how I would graph that line. Like I said, probably the most important thing about that one is being able to look at it and right off the bat knowing that it is a vertical line. Okay, and that does it for this set of problems. I will pick up our next video with problem number 33.